We want to look at intermolecular forces, right? And this is, again, chapter 8.1. So just so everybody's on the same page, this is not a part of chapter 4, but it relates to chapter 4. So we had our three main types of intermolecular forces. IMF, I'm not going to write that one again. And those are hydrogen bonds, which are not true bonds. Right? What do I mean by that? Not true bonds. So what would be examples of true bonds?
Covalent bond?
Covalent and ionic, right? So covalent or ionic bonds, right, would be the examples of true bonds. Hydrogen bonds occur between molecules, right? These covalent and ionic bonds occur between atoms. Oops. Does that make sense, guys? So when we're talking about intermolecular forces, we're saying that these are the forces between molecules. These bonds, covalent and ionic, are the forces that keep atoms together in a molecule, right?
Right.
Does that make sense, guys?
Yeah.
Cool. So hydrogen bonds occur between hydrogen and oxygen, hydrogen and nitrogen, and hydrogen and fluorine. So in order to have hydrogen bonds, you have to have one of these at least in the molecule that you're looking at. Does that make sense?
Yeah.
Cool. So the most common example of something that can do hydrogen bonding would be a water molecule, right? So a water molecule has two of these hydrogen-oxygen bonds, right? Which makes it really good at hydrogen bonding. And what we see with the water molecule, I'll draw it down here, is hydrogen's not very electronegative, meaning it doesn't want to hold on to its electrons too tightly. But oxygen is very electronegative, right? So it's trying to steal away hydrogen's electron. So what we end up with is a partial negative charge up here and two little partial positives down here, right? So you can imagine when we're drawing these Lewis structures, we're pretending like one molecule is just hanging out by itself, right? But that's not really how this works. When you have water, there's a ton of water molecules hanging out together, right? So intermolecular forces are the things that stick these molecules together in order to form solids and liquids. Does that make sense, guys? So we have all of these partial negatives and partial positives are attracted to each other. Am I speaking Greek?
Can you explain it one more time?
Yeah, so because oxygen is more electronegative, right? We have asymmetry, right? So in order to have a polar molecule, you have to have asymmetry. How do you know if you have asymmetry? Anybody?
If it has lone pairs.
Right. So when you have
Essential atoms.
lone pairs and polar bonds, will give you a polar molecule, right? So we know that water is a polar molecule, and sorry, my phone has some hiccups with Zoom occasionally, so it's frozen. Hopefully it'll unfreeze shortly.